Here's problem 513. The horizontal surface on which the object slides is frictionless. If F is equal to 6 newtons and M is 1 kilogram, what is the magnitude of the force exerted on the large block by the small block? First thing we want to do is make a free body diagram, and we're going to make a free body diagram of the whole blob. So we're going to blob the whole thing together. Total mass 5m, which actually will be 5 kilograms. We have a force of 2F on the left and a force of F on the right. Of course, we're going to have weight and a normal force as well, but they're going to be transverse to the motion, and the surface is frictionless, so we're not going to have to worry about their contribution. Ultimately, we're going to have an acceleration to the right. I'm assuming that the 2F is larger than the F, so hence our acceleration will be to the right, and that'll be our positive direction. Okay, so there's my free body diagram, and if I look at the forces in the x direction, that should equal my total mass times A, and that will equal the net force in the direction of acceleration. So that is going to be 2F minus F. M is equal to, or our total M is equal to 5M, 5 times the M as we have it, A, and that's going to equal 2F minus F, which is F. So in other words, A is going to equal F divided by 5M, which will be 6 newtons divided by 5 times 1 kilogram, which will be 1.2 meters per second squared. Alright, so that is our acceleration. That's acceleration for all the blocks. Now we can go more internal. We blobbed it together so we didn't have to worry about the internal force, but now we want to worry about, because that's what we want to find, is the magnitude of the force exerted on the large block by the small block. So let's do a free body diagram of the large block. Here's our 3M. We have this 2F force on the left, and we're going to have a reaction force, let's call it Q, pushing on it from the right. It's going to have weight, let's call it W1, and a normal force, let's call that N1, but they'll be transverse to the motion, and as a result of all this, it's going to manage to accelerate to the right with a value of 1.2 meters per second squared. So that is our new free body diagram for block number 1, the large block. If I set up Newton's second law in the x direction for this, the summation of all the forces in the x direction will equal total mass times A, which is 3m times A, and that's going to equal the net force in the direction of positive acceleration. So in this case, that's going to be 2F minus Q. Everything else is further away. This is what's happening on this block. Solving for Q, I have Q is equal to 2F minus 3MA. So that is going to be 2 times 6 newtons minus 3 times 1 kilogram times 1.2 meters per second squared. So that's 12 minus 3.6, which will give us 8.4 newtons. And it's coming from the right to the left, so we have a force exerted on the large block by the small block, 8.4 newtons from right to left, which would happen to be the same force that the large block is exerting on the small block going in the opposite direction, 8.4 newtons.